Yeah, just waiting in like great anticipation.
In the next, 5 to 10 years here, when space tourism becomes more and more mainstream, and then you're gonna have like people that you might actually know, or know someone that went to space. Are you gonna feel pretty silly about all this when you realize that it's just a meme started by a stand-up comedian and a yoga instructor?
Well,
is it gonna be silly? Are you gonna feel pretty silly? I mean, I'm being honest here with you, Witsit, because this stuff on the internet, it's forever. It's like it's like the 18-year-old girl who does a porn gig for like $500, not thinking much about it. It's gonna haunt her for for the rest of her life, because they're gonna just type in her name like, oh, look what she did here on this date. You know what I mean? Like, you're not worried about that? Witsit?
Are you not worried about like saying all of that with all of that conviction, and whenever they put it off like another couple of years, you'll just act like that's no big deal, and you'll do that same spill for the next 30 years. They've been putting it off for like 30 years, and people now are going to keep doing it until they just never do
I'll tell you my conviction with it.
And my answer to your ultimate thing is basically your backhanded subversive way of trying to say that I've gone out on a limb looking stupid to everyone.
You haven't gone on a limb.
Irreparably.
Let Jake respond to it. So I guess up to you.
Well, I mean, my conviction, I think Scott Mackey has said this. If somebody were to come to my door and say, look, here's $1 million if you're willing to take a bet against the life of your family that the earth is flat or not flat, I would feel very confident to take that bet, and then I could go tell my wife that we're millionaires now.
You would not take that bet.
I think all of us would feel confident to take the bet.
Everybody,
you would take the bet with your wife's family on it. You would take the bet
with my family. Yes.
Yeah,
yes, because that $1 million
with your family's life on the line.
Absolutely.
I've never met anybody in Jake's family. I'd do it easy.
You're a psychopath.
You said commercial space travel is going to be, there's going to be a lot of people going to space. Are they going to do one of those bullshit Virgin Atlantic things where they go up for 5 seconds and come back down? Or are they going to be going?
Well, they'll definitely go high enough to see the curved Earth.
Oh yeah,
right?
definitely. So, hey, do you agree?
For my life on the line flying, we have an artificial horizon. We have we know that the Earth is curved.
Oh my gosh, what an idiot!
Just going up there.
And I'm the idiot. If the horizon,
this dude just said you can tell Earth's a ball by getting in a plane, dude. Are y'all gonna let him do that?
Yeah, by looking at the horizon below level. Yes.
No, because you're going up above the ground.
Yeah, but the horizon drops with altitude.
1v1 on this one. Sure, go ahead.
Yeah, it drops with altitude because you're getting higher above the ground.
Yeah, that wouldn't be the case on a flat Earth, though. That wouldn't be the case on a flat Earth. You can model that.
The reason it would be like that on a flat Earth is because you're going higher and higher up above it, so it's below you, but it starts to rise to you. It just doesn't rise all the way because you're getting so much higher up above it. What you're actually seeing is an optical vanishing point based on the ground and the sky. You have to interrupt me, dude. So anyway, do y'all agree at least, so I don't have to go like prove y'all wrong, that within your own paradigm, they cannot explain the magnetic field on the globe Earth? They admit they're trying to figure it out and they're proposing all kinds of different models and theories.
Can I ask you very briefly what you just said about raising yourself up? Would you admit, or do you at least understand that if the plane was flat, that the horizon would drop or rise at the different rates depending on how far that where that flat land extended to? If that flat land extended infinitely, it wouldn't drop at all. If it extended to some other range, it would, like I said, drop appropriately to whatever that range.
It's based on where your vanishing point is, which is based on the atmosphere and how high off the ground that you are, dude. And when you're higher off the ground's more below you, dude.
Nope.
So you're saying if it was an infinite plane, it would still depend on your vanishing point, is what you're saying.
Yeah, you're saying if we looked out over an infinite plane that we'd be able to see forever?
No, I'm saying if you look on an infinite plane, then that line would be eye level.
I wouldn't. I know it'd be really close to eye level, yeah, but like it would be.
But it's nowhere near close to eye level.
No, it comes up. It doesn't go down and away from you like on a globe Earth. It just goes down a little bit, but still rises up because you're going up.
Dude, it goes down a lot. What do you mean?
No. Actually,
it goes down up. 3/4 of a. Hold on, the horizon drops 3/4 of a degree when you just go up 1,500 feet, which is nothing.
Okay,
and then
when you go up, when you go up off the ground, you're higher up off the ground. The ground is now further down below you. It actually comes up whenever you're talking about the optical effect of the vanishing point or the horizon, and that constantly changes. That's an optical location, apparent location, changes based on the atmosphere. That comes up to you. It's where it looks like the ground comes and meets the sky, but it doesn't have to go all the way up because you're getting a certain amount of altitude. That's a variable of how high up off the ground you are. You're looking at something below you, dude, but it rises perceivably. It doesn't have to rise to a certain way. It is coming up, but it's down below you. It's not complicated. You people are trying to whistle past it.
The only reason it would drop on a flat plane is if it were a finite distance, and it would drop not according. It would drop according to the altitude, but also according to the distance that finite plane.
Right.
Is.
Why are you not talking about the atmosphere though?
Because that doesn't matter.
See, that's why you're wrong.
Right.
Well,
so the atmosphere would somehow create a line.
No. Where you see the line is dependent upon the atmosphere.
Yeah, that's what I was saying.
Yeah. So do y'all agree that your model can't even explain the magnetic field?
Though, Witsit, if that were true, there would be no reason why we still get the same R value when we measure how much drop we have at a whole bunch of different data points, right? We measure at 2,000 feet, 5,000 feet, 10,000 feet, 15,000, 20,000. You keep going up, and you keep measuring the drop from the horizon, and it always yields the same R value, even though you're looking through entirely different atmospheres.
That's totally not true.
That is indeed true.
It always gives the exact same R value.
It gives within the same range.
Within a very narrow range, you'll get the same R value.
Yeah, we're allowing for the slight error, measurement error, or whatever, but it's going to be still like when one time me and Curve were talking about this, and we were just sitting and talking. We weren't looking at data or anything. We just did the numbers on top of our head. I remember that at an average height of a plane, the horizon would drop by about 3 degrees, somewhere around there. And just did this simple math, and just using that equation and using the same method that Al Bruni used, we got within, I forget what it was, but it was like a little bit above 4,000 miles for the radius. So it gives you within the correct number. It is a cool story. I thought it was cool.
It constantly fluctuates, and it's an approximation. You didn't even
It doesn't fluctuate.
My point.
It doesn't fluctuate. That angle. Do you know how little that angle fluctuates?
Oh, but I thought it didn't fluctuate.
It fluctuates a tiny amount.
So you're wrong then. So let's move on. It fluctuates and you take an approximation.
A tiny amount.
Yeah, like when
look, all you're doing is reverse engineering.
Seconds, and we're talking about.
All you're doing is reverse engineering the limitation of optics. All you're doing is reverse engineering the limit of the optics, and then you're getting an angle. It's going to fluctuate. It's going to fluctuate.
Sorry, bro, but the evidence is that the Earth isn't flat. I'm sorry, bro.
Yeah, I know it's like really disappointing. Dumb things.
All you're in this basket, but you know what, Witsit? It's just not the way it is.
Oh, wow, you really knocked that one out of the park. That's why we let him finish, I guess. So, anyway, all you're doing is taking an approximation. It fluctuates. Everyone knows this is objective. You're looking at an optical effect. You're reverse engineering the limit of your optics. That's what you're doing. They're assuming some physical location, which is clearly not there because the fluctuation itself disproves the notion that it's physical. You don't know what you're talking about, but the people just you claim victory. Somehow that's right.
So
get back to the point when I left here. Y'all, I thought I gave you all that time to just
but you took all that time to say that. You should have said what you wanted to say instead of that because that was the time that you had. Okay. Try to make 1 point at a time.
No, that's me addressing. That was me addressing that. Can we go back to the original?
That's fine. Well, then that's what I'm saying. That's your point. Then, like, you're saying 5 things or what?
Well, can we go back to the magnetic field thing? Like, y'all agree that you can't explain the Earth's magnetic field on a globe Earth. It still hasn't been adequately explained.
Of course we can. What are you talking about?
There's not even an agreed upon explanation. They're proposing a whole bunch of different theories to try to explain it in different models.
Name 2 of them.
Okay, I can't. Okay, well, there's like the idea of the dynamo model itself is the idea that this body of the Earth is spinning, and because of the convection, because of the movement and the energy, that it's going to have some effect on this magnetic field, which is actually going to culminate around the outer core. So that's
the one that I know.
Okay.
The other one.
Well, that's just dynamo in general. That's a general idea. Then there's like the geodynamo, which is a little bit different. I can't remember the other names of there's like 3 more, and they explain the different.
How is a geodynamo different from the dynamo?
It's not that it's different. It's a type of dynamo is just explaining that it is the base of an Earth that spins, and it's like spherical, or just an Earth that spins. Okay,
we'll agree that there's just one. Then.
And geodynamo is the same thing that you just said. It's literally the same thing.
But the dynamo part is the part of what that means is that what it is inherently is that it's the convection or the movements causing what is the magnetic field. Okay, so that's one thing.
Do you know what the word dynamo means? Why they call it a geodynamo? Do you know what the word dynamo dynamo means?
Yeah, there's a dynamic nature of the magnetic field.
You know that often
that's what it means.
The alternator, you know that often the alternator, especially in other countries, is referred to as the dynamo.
So do I have to? I guess I'll just go get
in a car.
I'll go get where it says that. You're wrong.
Yeah, a dynamo is a mechanical machine that converts mechanical energy into electrical energy.
Okay, so the dynamo theory, requirements for the geodynamo, homopolar disk dynamo. Homopolar disk dynamo, you come down here. You got kinematic dynamo model. You got the turbulent dynamo model.
You're putting the wrong emphasis on the wrong syllable.
Seriously.
Okay.
Dynamo, baby.
Dynamo. So these are all different models, and you said that there's not any, so I guess I'll send Harvard over to you guys, and you can just continue to argue within your own framework or paradigm.
Yeah, as long as they're in duct sites.
These are all proposed models. I tried to explain it because it's not adequately explained. I tried to tell you people this. I didn't get this from Nathan Thompson. I looked at this.
No, not you. I was talking to the other guy.
Okay, so, I mean, can we just at least concede? I guess I'll just post it first.
What? You said you're going to concede, or you saying
that they can't really explain it, and there's a whole bunch of different types of models. You said that there's only one.
You said there's a whole bunch of different theories on what's going on, but the dynamo theory is the only one I know of. I asked you if there was other ones. You said it was a geodynamo.
There's different versions of a dynamo theory. There's different versions of a dynamo. That's a base, dude. That's a base of the fact that the Earth is spinning and causing it because of the
there might be differences on the details of
No. Trying to explain it. Why don't you read it?
Ultimately, they are all based on a spinning iron core.
Oh, dude, you want to try to read it maybe first?
Sure, show it to me. I want to see where there's a theory that's not based on a spinning iron core.
No, what they explain is the problem with each different type of way of figuring it out based on that assumption. So it seems like you're just behind.
Yeah, but all of them have that assumption.
Before making yourself look stupid, just click on the Harvard link and look at it.
Do all of them have that same assumption though?
Do they all assume that the Earth is moving and
that the magnetic core is a response to the fact that the core is rotating and the Earth's rotating on it?
Well, not exactly the makeup of the core. So that's what the whole point of the different theories are. Yes, dude. Of course, it's all central to the center of mass, dude. This is all under the assumption of the Earth being spherical with the center of mass, dude. Jesus,
and what else?
Bro. Okay, so this is the issue here. We have we have the dipoles, but then we have what we know not to exist, like monopoles. We're trying to explain it within it. Are there monopoles within it? Because there aren't really such thing as monopoles. This extends into the idea of like quantum mechanics, even right here. So the fact is there is no such thing as a monopole, but based on what they have a framework of, they would expect to find it. Okay, and this extends on different levels and different scales, quantum and cosmological. And I just now posted to you the local scale. So just check it out. There's different types of models. They're explaining what's wrong with it. Like right here, like with the kinematic dynamo model, right?
Yeah, all this is doing is explaining what dynamos.
No, it explains does not apply to geodynamo. Numerical simulations of this model prove important for the understanding of MHD equations. So it ignores the back reaction effect of the magnetic field on the velocity field. So there's different ways of how they're trying to interpret it because they can't explain it. And
literally this paper is just arguing over different distributions of the magnetic field in the rotation.
No, that's trying to explain the distributions that haven't been. No, it's about not being able to adequately explain the distribution of the magnetic field. So maybe you should read it.
They're all based on a spinning magnetic field
Oh yeah.
generated within the Earth.
Okay, are you gonna read it and explain
I
this?
did. I looked through the document.
Yeah, it's pretty quick read.
They're showing models of different distributions of the magnetic flux.
Okay.
They're all based on this spinning molten iron core
dude,
model.
that's what I started with saying. That's what dynamo means.
That's not what it
And it's
means.
dynamo.
That's not what you said.
We get
That's
it.
not exactly what it
The
means.
first thing I said was I defined dynamo objectively. I said it's the idea that the Earth's spin and convection, its velocity, its movement, its energy is affecting the magnetic field. You're going to try to explain. That is what I said. No, I didn't say dynamic. God.
Let's just go ahead and wonder what's the point then if.
Well, my point is I can't explain it.
I mean, they're explaining it by saying the dynamo, but if they're working out the kinks and
because it doesn't work, they're trying to explain it. So anyway, mathematical framework. The quantitative measure of how well the dynamo action will hold up against the dissipative effects is given by the Reynolds number, where U is the velocity scale and L is the characteristic length scale of the velocity field for any dynamo action. Otherwise, the decay term would dominate and the dynamo would not sustain.
Where did it say this? So I can, because I wasn't listening.
Hey, you mentioned Reynolds numbers.
Page
You know what
13.
Reynolds numbers are? What's it? Can you tell us about Reynolds numbers and how they pertain to fluid dynamics?
Go ahead, Jake.
Then why are you reading it if you don't care?
Because my point is I've looked through this before and it says right here that they're not able to explain it. That's why there's all these different models, different mathematical frameworks to negate certain things that don't let them explain it because it wouldn't be able to be sustained. And you people argue it until I pull out Harvard. Then you still argue it. You say Harvard's not saying what it's saying. Then I have to go through it and read it because you said you're Superman readers. You looked through it already. Then I'll read a specific page, tell you clearly it's saying what I'm saying. And now you're still going to try to flip it like I'm ignorant of the subject that you're clearly ignorant of.
Dynamo. Did you hear what I said
a
about
model
the
that works out all of the individual little details
when they're in the southern
does not mean
hemisphere
that they're not working
and
on
not in the
models
northern
that
hemisphere?
explain the same thing.
Did you hear what I said about that, Witsit?
Jeremy, you talked over Slacker, and
I know I did.
Yeah, I know, but we're on the topic. This topic, real quick, you know.
The topic of magnets and dynamos and Earth's magnetic field and shit, right?
Yeah, you can't have a magnetic field with monopoles in it. We have to have a quadrupole. We're lacking a convergence of sustainability. That means there's a landmass that's sustaining it pretty logically. But either way, objectively, they know that they can't fully explain it. They would expect to see like a monopole, an idea of like an electrical charge, right? Because it's just by itself. It doesn't have to come in pairs and have like the north and the south pole, right? But they don't do this. If you take a bar, they try to look at the Earth like a bar magnet. If you look at the Earth like a bar magnet, right, and you cut the bar magnet
at a time, okay? Where does it say you need a quadrupole?
Well, they come in pairs, like poles come in pairs, like because we have the magnetic flux that we do, and it just yes, we have the dipole, but we also have additional flux that wouldn't be just because of the dipole. So that means there would have to be another dipole. They come in pairs. That would be a quadrupole. But they are trying to explain the phenomena underneath the. They're trying to explain the phenomena underneath it being the idea of a monopole. So if you all don't know that, I'm citing it right now. I'm sourcing it for you. In all parts of the physics that you adhere to.
At the very beginning, magnetic field of the Earth. The very first words, dipole field structure. 80% of the field is a dipole. 20% is non-dipole.
Okay, thank you. I've already read it.
That doesn't mean a monopole.
I've already read it, Kosho. Stop trying to read it to me.
Yeah, but that's not the same thing as a quadrupole or a monopole.
Okay, read that again.
Saying that there's fluctuation.
Read it again.
10% is dipole. 20% is non-dipole.
Okay, so what is it then? Where is it then? What is it?
Nor is it monopole. It doesn't say any of that.
If it's not dipole, no, keep reading. If it's not dipole, what is it then?
A bunch of other things. There's going to be monopole or
They're trying to understand. There's no such thing as a monopole. They're trying to explain it. So how about you read the article then? How about you actually read it?
Talking about the large-scale structure of the magnetic field, right?
That's what I'm talking about. Your model can't even explain the Earth's magnetic field.
pages saying on this whole thing that monopoles or quadrupoles.
Don't have to make a perfect dipole to be made out of things that behave like dipoles. The large-scale field can be.
You people are ignorant of the subject. Why are you trying to teach me?
Somebody mute him. To be a perfect dipole.
You're the only one in the room who learned in the past 10 minutes how to even say the word dynamo, and you're telling us that we're ignorant on it. That's not very cool, man.
Okay, it doesn't mean that you aren't ignorant of it.
Yeah, no, that's what I'm saying. Ironically, you're the one stating that. The guy who just learned the word.
No, I can just say dynamo if I want to, bro. You're a clown, and you don't even understand what it's talking about. You don't. I just had to teach everyone in here about it, and they argue about it. Then they get Harvard telling them exactly what I said, which means they shouldn't have been arguing ever. Then they whistle past it. Now we're going to continue to whistle over here to the next point you'll whistle past. You can't explain the magnetic field on the Earth. I'm almost done. You can't explain the magnetic field on a globe Earth model because only roughly 80% of it can be explained with the dipole, the acknowledgement of the dipole. You have 20% of a flux of magnetism you can't explain, and that is actually a low number based on some of the other theoretical assumptions.
I heard it was just flux in the field. But again, what are you coming in here and teaching people things about this that people didn't know already? Like what
if it's outside of the dipole, then that means something else is helping get sustained. So is that electrical that's acting like a monopole? Do I have to just read the articles word for word from your priest? Is that the only way people
saying it says? So there's no point in reading it word for word.
Which one have you looked at? I have numerous ones. Each one I'm sourcing is to make the point specific that you can test. Y'all can test every part of it. So I got to give you articles for each one of them. And you people want to say, well, if everything I'm saying about it is in one article, no, it's covering one subject. Now you're going to contend something else you don't understand or know anything about. So here's another article. Then here's another article. But you never keep up and you never examine it.
Do any of them have a different model other than dynamo? Because that was what was originally stated, that there's all these different models of what's going on. But, I mean, if it's a dynamo, then that's the model.
My point was they still haven't agreed upon or know how to actually explain the magnetic field on the Earth with an accurate model, and you people contended it. And then I gave you Harvard telling you the same thing, and you people are still going down swinging.
Said that they had worked out all the details.
Oh, they don't. I said they don't have a model they agree on. They can't even explain the magnetic field within a model accurately yet, and you people contended it.
Like I said, they all are dynamos. They all have the same general model. There's slight variations in, it doesn't even look at slight variations.
There are different attempts to try to explain how it's possible. That's what there are.
What would be a different attempt? A dynamo has to do because of the rotation of the
right, so everyone's assuming that we know for a fact, because listen, everyone's assuming we know for a fact the Earth's rotating. Now, with that assumption, knowing that would affect the magnetic field, 100%.
What other explanation is there other than that one?
Listen, dude, calm down. Everyone assumes that the Earth is rotating, so there's not going to be another explanation from higher education other than that. That isn't something that people even consider. Why are you always interrupting me?
Because you don't make just one point. You go on. You have to just make one point. If you're asked a question, just answer the question. Don't answer the question and then make 5 other points.
No, you just don't want me to give the full context to the viewer so you can misrepresent.
No, because you just corrected yourself from earlier. Earlier you said there were all these models. Now you just said, oh well, of course they think it's this because they're high.
No, I'm not even. That's why you have to interrupt me so you can strawman me. That's why you have to interrupt me. You have to censor me.
Shut up.
So let me know when I can actually say what I'm saying. Okay, so yeah, everyone's already assuming the Earth is rotating, right? So that's where you're going to factor in the dynamo part, right? So dynamo.
So is that the cause of the magnetic field, or is there another explanation?
Listen, that's where it comes from. Now, everyone assumes that to be known. So, yes, every model that has been proposed has that in it. That's the base foundation. That's the idea that the movement, the convection of the velocity of the movement of the Earth, that's what it is, okay? It has an effect on the magnetic field. Now, everything outside of that is what people are trying to explain, because they're trying to explain how what we observe and know about the magnetic field could work within that assumption. And no one's been able to adequately do it. That's why there's numerous different theories and models trying to still do it.
There's no disagreement about that. But the disagreement was about the explanation for the magnetic field, which there aren't multiple explanations for. That the same general explanation is that there's a dynamo from the cause of rotation. That's fairly consistent, like you just stated.
Yeah, but they're trying to explain how that's possible with what we actually get based on the magnetic flux in the field, dude. And they still haven't been able to do that. That was from this year.
Witsit, it'd be nice if you could remember your own arguments.
No, you people just misrepresent and never understand or remember my arguments.
You tend to modify every
Remember
argument
when you
on
said
the
it's
fly.
a dynamo because it's dynamic and tried to connect the words that way?
Oh wait, I said there's a dynamic characteristic of the magnetic field in flux. That's objective.
And that's what you said dynamo means.
Yeah, because you're introducing a change to the actual magnetic field because
Okay,
you
so
say
you
that it's spinning.
agreeing with your old argument. Okay.
You people are ridiculous,
do
man.
that occasionally.
You don't even understand the
A minute ago,
arguments.
You said you didn't say that.
You don't understand arguments, and then you say they're wrong.
It says in your own article, it says supercomputer simulations are able to very closely model the Earth's magnetic field.
I was just about to say that.
I know that. I read
Did you miss that quote?
No. So that's what it. Do you explain how they did that? They go up there and they say you have to negate a certain factor with the mathematical framework.
They don't negate certain factors.
Okay,
They're
so
trying
I'll
to
just go
take into
read it
account
again then, because you're a
differences in the
liar. But
fluid
what's a
flow.
shocker? You are always a
If you
liar.
look through
What's a
that
shocker?
paper, they're looking at differences in fluid flow, and Coriolis is part of some of those differences. They're
We're
also
all shocked
looking
you're a
at.
liar. Trust me.
Oh my gosh, what's it?
I've already cited it. I'm going to go back and read it again.
Well, yeah, your paper doesn't prove your point. Your point
Okay,
was that there's
mathematical
competing
framework,
theories.
quantitative
Your point
measure.
was-
Let him finish his quick point. Ed.
But he heard me say this already, and he's ignoring
I'm
it.
saying let Jake finish his
Yeah,
quick
your
point. He
point
was
is
done
that
to speak
there's
forever.
different models to explain the Earth's magnetic field, and there isn't.
Okay, so every single model is what's called a dynamo model. That is just an overarching label because everything has to be explained within the framework of the spinning Earth. If you don't acknowledge it, then you couldn't explain it because everyone assumes that to be known. No shit. So inside of that framework and that assumption, people have yet to come to an agreement on what it is. There's something wrong with everything that someone proposes. This is objective. And this is what I'm saying. Otherwise, the decay term would dominate and the dynamo would not sustain. It wouldn't sustain, bro. So
That's just
dynamo.
that says that
The dynamo
our
wouldn't sustain. The dynamo wouldn't
that says-
sustain.
If they're able to model this with supercomputers and predict the
Because of the
fluctuations and
mathematical framework,
variations that
dude.
we're seeing,
Let him finish.
They model it with the mathematical framework. He's skating past it again.
Hold on a second. So we should throw this away and then accept the flat Earth version of the magnetic field, which is who knows, right?
Well, have you seen the magnetic flux mapped out over a flat Earth? And actually, I know that what they say the flat Earth is. There is no. That's the reason I don't claim a model because I'm not a dumbass, and I know there has to be a quadrupole.
So we
there
should
has to be a
replace a model
quadrupole.
that can.
There has to be a quadrupole on Earth to have what we have.
Model with I don't know.
Listen,
should we
man,
replace a working model with I don't know? What's it?
No, this is what we need.
The flat Earth who knows model. Should we replace it with that?
I'll
Can
let
I
Jake.
answer? You're a clown.
Answer his question though, but don't keep
Okay, so, well, to sustain what I know has to be here, which is a quadrupole, then you would have another landmass, which means there's a landmass we don't understand that, or don't know about, that is actually sustaining the quadrupole. So if that was the case, how could I make a model without knowing where that was? And whenever they give us the data of the magnetic field limited on the amount that they allowed us to explore, because there are rulers, then we don't get the fourth convergence point of data.
That point you're quoting just says
our
R
magnetic
subscript.
field to land masses. That's
Yeah,
weird.
dude, a quadrupole? How would the quadrupole be sustained without land there to sustain it?
I mean, the
But
dipole.
you do realize that non-dipole means that it doesn't reach towards the main poles, right? It's
You
still
do
a dipole,
realize
it
that
just
there's.
doesn't
Do
reach-
you
it
realize
doesn't
that
reach
there's.
towards the exact north and south pole. That's the issue. It's not that it's quadrupole or monopole. You should learn what the fuck you're reading, you idiot.
Yeah, you still don't understand. So, with the most of the magnetic readings that we have, right, you can explain with the north and south pole or the dipole, but you can only explain a certain percentage with that. There's more than that that cannot be explained with the dipole, literally. So they're trying to figure out how to explain a hypothetical idea of a monopole, and it could be something to do with electric charge. They're trying to figure out what it is because an electric charge is basically a
monopole.
wow. Electric charge has nothing to do with a monopole. What?
The dynamo effect has nothing to do with
I guess I'm
monopole.
just
When
going to
you're
source
reading non- when
another
you're reading
document. You people are
when you are reading
morons.
when you are reading non-dipole, that is meaning that it is not extending towards the traditional two poles at the extreme. That is
Okay, so what does it
non-dipole
mean when it
comes
says
to the dynamo
monopole?
effect is.
He
What
just
does it
told
mean
you
when it
what
says
it meant, man.
monopole? What's it mean when it says monopole?
Doesn't say that.
Okay, so I guess I'll have to cite some more.
This isn't about like fundamental sections of magnetic.
And I told you this extends into all parts of physics. You people are just lost.
This is about the large scale field of everything that's affecting it going together. You can make a field that doesn't match a perfect dipole without using monopoles on the large scale.
All right, cool story.
Yeah, guys, let Phil.
Making it up don't have dipole fields.
Go ahead, Slacker. I was just say let Phil get in there next, just because I could hear him trying to get in there at some point.
Okay.
If you still got something to say.
Thanks,
Well, that was
Gosha. The part that he keeps quoting about, or it would not sustain, all it says is that the value r subscript m has to be greater than 1, or it would not sustain. That doesn't mean that there's a problem. They just know that this one value has to be greater than 1 for the model to work.
It's a control variable. It's a mathematical framework.
Exactly. So it's not saying it doesn't
Okay, so it's a
sustain.
mathematical framework of assumption to be able to ensure more accurate results, because it wouldn't work
So
without that.
Why don't you quote something that agrees with your point?
That does agree with my point. You have to make an assumption, a corrective assumption, a calculative, addition to the information. More so, you're restricting the information. It's a mathematical confinement. It's a mathematical framework.
So?
So what do you mean, so? That means that it doesn't work unless you make an assumption, calculative assumption that isn't consistent with what you're actually getting. You have to make a calculative assumption.
Where are you getting that it's not consistent with what we're actually observing?
Dude, the mathematical, because you're negating what you're getting because it would overcome it. The dynamo wouldn't be able to sustain. It says it right there in the paper from Harvard. You people had access to for 30 minutes now.
Okay, wait a minute. Where is there an actual observation that this value is not what I say it has to be? Because that's what
you're talking all of it. Yeah, we're getting all the magnetic. Dude, we read fluxes in the magnetic field.
No, I'm not talking about that. I'm talking about this value that they're saying has to be within this range for the dynamo to sustain. Where is some observation that contradicts that you're suggesting?
No, based on the observations, they have to use a mathematical framework that accounts for not allowing this value to get bigger than a certain amount because it would overthrow the dynamo.
Okay. Are you saying that contradicts observation?
No, it doesn't contradict observation because the mathematical framework was literally created to explain the observable phenomena, dude.
Does that mean they're consistent?
What's the problem?
The problem is that you are having to add a mathematical framework to negate certain variables so that you can still propose the theoretical possibility or viability of what you're claiming, i.e. the model.
That negation thing is what I'm asking. Where is an observation that is being negated?
So you're limiting the value to only go so high, right? The characteristics length scale of the velocity field. So you have a limit, dude. Okay, for any dynamo action, it can't be, what does it say? It can't be less than 1?
Yeah, it's going to be greater than 1.
Exactly. So
isn't that
otherwise,
it's an observation though?
No.
Observed to be greater than 1.
Then nothing is being negated. It's just being
limited to the confinements of what could even be viable with a mathematical framework.
Okay.
Okay, well, that's what my whole point is. You people just instinctively want to contend every single thing I say, and I'm reading Harvard.
No, you're saying
you keep redefining each portion of it, and then you bring it up in a way to where you're arguing something it doesn't say. And when you get called on it,
no, what it says objectively is they're trying to explain and propose different models to explain.
You should never use the word objective because you subject it to so much fucking torture. It's unbelievable what you come up with.
Yeah, well, my entire premise was very simple, that your model cannot adequately and definitively explain the magnetic field on Earth yet. And in fact, so you agree that you can see the premise?
Which one of them? And will you change it?
That they don't have a definitive, accurate model to explain the magnetic field on Earth, and that they're still proposing a variance of different postulations and theoretics to try to explain how it could work.
We do not claim to have a model which is 100% precise for every prediction. It is an ongoing work, the same way everything in science is.
No, it's not even close.
If you want to say that we are going to make claims to 100% knowledge on things, then you're going to have to back that up. everything in science is tentative,
if it's
and you're
not even
treating us
close,
like we're
where's the
100%
observations that
the gatekeepers
contradict
of knowledge.
Okay, because we can only explain 20.
Was that there's that nobody understands the magnetic field. That's what your original claim, verbatim.
Yeah, y'all don't even understand what the globe Earth model says about the magnetic field. That's correct. Obviously, you've just demonstrated your ignorance this whole time.
No one in the world understands the magnetic field. You said no. You said we don't. No one. You didn't say no one in this room.
Yeah,
You said nobody understands how the magnetic field on Earth works. That's what you said.
What I said was even at the highest levels of education, they admit that they don't fully understand magnetism or have a fully agreed upon denotation of a field, which are intertwined.
If people would have agreed with you if what you said is they don't have a complete understanding of it. But like I said, that's not the same thing as what you said. Was they don't understand it, but we do have an explanation for it, and they're all consistent in the generalities of it. I mean, the only inconsistencies are the things that are actually inconsistent with the Earth, like the anomalous field in different locations.
All right, well, dude, I try to explain it, man. It's like this extends into different parts of physics, and that's just objective also. And so we're looking at the Earth and the magnetic fields, and then we're trying to understand how it could all be sustained. And if this is acting as if independent of a dipole, then how could that ever happen? And then it's more so proposing coming into the idea of where magnetism is synonymous with electricity. And that's what some of this that I've literally already linked to you is explaining. So
why would you say they're synonymous when they're not? They're two parts of the same.
No, it's the theory that that they would be. So, but it's not even like the point is this is your own paradigm. I'm just showing you guys like your own paradigm at the top of it. They don't all agree on this because it's unknown. And like we should just be able to agree on that part because it's just like that's what it is.
They don't agree that it's from the rotating Earth and the rotating core. They think it's something else.
They have to assume that that the rotating core is a factor because that's a movement and a gravity pull of center of mass. They have to.
If they took that out of it, then they would have no idea what's going on. That's what would happen. If they took that out of the equation, they would say, "Oh, I have no way of even coming up with an idea."
Not true. That's not true. That's not true. If you take the sphere out of the equation, it's very easy to explain.
You can have the rotating core and all that kind of stuff. There's no other explanation. There's no other idea of why there would be.
You're right because it's a stupid postulation. The Earth is spinning in a ball. Yeah, and that gravity center of mass. It's stupid.
How in the hell did you get that out of what Kosho said?
That's what I'm explaining. Like you can only explain it on a flat Earth.
No other viable explanation if you take the sphere out of it makes the sphere stupid?
Yeah, like no, the only viable option is without the sphere. It makes the sphere is stupid. Magnetism makes the sphere stupid.
Once again, you did not listen to anything that was said whatsoever.
You're not listening, I don't think. You're self-projecting.
I don't think you even have ears sometimes.
I bet you don't even know what I just said.
I don't care what you've just said. All you said is you think I'm stupid and not listening.
I did not say that. I said that. Yeah, like you can't. The magnetism shows that the spherical and spinning spherical postulations are stupid, but you can explain the electromagnetic field on a flat Earth.
Okay, I know. So go ahead and do that for us then. That's what I was stating. That there's no other explanation other than the one we have. But if you have one that works on the flat Earth, then I'll be happy to hear.
Yeah, there's an electromagnetic field encompassing Earth, and the Earth is the dielectric plane.
Okay, what's that caused by? Is really what the question is.
What is what caused by?
The magnetic field that we're talking about. What is
the same something in the central point is magnetic. Everything seems to have a drift. Well, there's a field there's a field over the Earth that has a drift that's consistent, just like a magnetic field would be. It would have one direction, perpetual drift. It's autonomous. It's governing magnetism field, right? That's like the only real field there is. So it's constantly moving. It moves in progression or in synchronicity with the sky. And we can measure this. And so we know there's electromagnetic field, and of course the Earth itself would be the dielectric plane. So the Earth is so big. Right, although inherently electrostatic and everything always has an inherent electrostatic potential, it's very weak. It's the dielectric or inertial plane throughout the electromagnetic field.
Saying a lot of words, but them are an answer to.
No, it's the only viable option. I'm trying to explain to you. You don't even have as much as I have.
Describe it. I'm asking you where it comes from. What creates it? Like I said, the dynamo is
central
for why there's a magnetic field.
The central point.
I'm saying, yeah. So that's what I'm asking: is why is there a magnetic field on this Earth? Like, what created it?
We're not even allowed to go over to the center, so I don't know what's there.
I'm saying there's no other explanation.
You're not allowed to go over direct center.
Jesus. So we should just throw away what we have with the flat Earth explanation, which is we don't know. It's a mystery, just like the moon, just like the sun, just like the stars.
It's very simple.
Do you agree? Hold on, Witsit. Hold on a second, guys.
Electromagnetic field, and it emanates from the center.
Witsit, will you agree that in the flat Earth, there's no explanation for what the sun is, what the moon is, what the stars are, right?
We haven't made up fairy tales about the very characteristics of the sun and moon.
That's not the question. The planets. Do you agree that we don't have explanations
no
for
one
these?
cares.
Do you agree
you don't
that
have anything? No,
Witsit,
you
why
don't
won't
have
you
any
answer my question?
I'm trying to. Your answer is no. You don't have.
Do you agree that in the flat Earth community, there is no explanation for these things? They're mysteries, right?
Well, there are all kinds of proposed speculations, but that's all you have. And in fact, you don't even have that because you have yet to
forget
actually
about
think
what
about
we
it
have.
yourself.
I want to know, what does the flat Earth have about this?
You
stuff?
asked about what you have, so you don't have. You're asking implicit that you have it, but you don't because you haven't come up with anything.
But generally
all you're
speaking,
doing
when
is
I ask questions,
you always have to interrupt me.
And you're not. You're telling me that his questions are relevant. You're not answering. He wants you to answer his question.
But you agree that there's no explanation, right?
You don't have an explanation.
Right.
That's not the question.
We got that far. We got everything the globe has. Now he's asking about.
Said yes. People theorize speculations. I already said that.
Okay.
Don't have explanation, please.
I have more viable explanations than you do.
Like, why does everybody see the same face of the moon on the flat Earth? And why is it always a disc? Why is it never?
The Earth isn't. The moon
like
isn't solid. What if the moon's a naturally occurring hologram through the polarization of the electromagnetic field?
Why does everybody see the same side of it? Why does everybody see the same side of it?
Because it's not physical, dude. The reason you say we see the one side of it is because it's a sphere that spins at a perfect speed. So if it's not physical,
you're saying in the flat Earth, the moon is not a physical object. In the flat Earth community.
Is very short explanations.
Yeah, you asked me to speculate. I'm explaining.
So is it true that in the flat Earth community, the moon is not a physical object?
You don't have the ability to think for yourself.
I admit that you have no evidence for what you're saying.
I can't think for myself because
I've already said I don't make definitive claims about what the sun and the moon are. It would be inherent speculation. Shut up! I'm still talking. As soon as he tried to pull the speculations out of me after I literally tried to say it's just speculation like 3 times, then he says, "Oh look, he's saying flat Earth's position is," and says like I said it definitively. Because he's a gamma male, and this is ridiculous. I'm not claiming anything definitive. I'm saying your models are fake.
Where you have to go.
I would to finish his points, but you gotta make them shorter than even that. Okay, they shouldn't be run-on points.
It wouldn't be that long if I could do it in the time, dude.
Literally, all the Globers in here speak for 5 to 10 seconds at a time. You go on for minutes. A Glober tries to come in here, and you just interrupt them, and you just keep talking and talking. I mean, if we had timers going, it would be like Witsit 5 hours, and all the Globers combined might be 5 minutes.
He's not wrong. He's not wrong.
When there's 10 people addressing me at the same time.
To the point that Witsit
Of course it's not the same. There's numerous people addressing me, cheerleading from the sidelines and capable of one-on-one engagement, trying to help each other out with obfuscation.
We'll all do better,
That was
but like
literally
I said,
7 seconds, and I still got interrupted. You people just don't like to hear it.
We're all gonna do better, but just by keeping that simple thing where it's just you keep them short and they won't interrupt. We'll keep it that way.
As short as in time, I always do. I just say a lot of words, and you people like that means long.
No, it's not the words. It doesn't matter how many. It doesn't matter how fast it is. What you're saying, you say a lot of things in the one time. You got to be making one point so that when people address you, they don't have to say, "Wait, he said that. He said that." They see the one thing you said and they can respond to it.
But if they will respond specifically, I would love that. It never happens. So let's get to it then. I said the only viable option that you can even postulate is an explanation, understanding that the Earth is a...
You know that because pineapple upside down, purple upside down, let's say purple again, no one can fucking address the point.
I agree with that, but Brian, you even in that, so you just got to let him finish it because hopefully he was going to keep it brief.
That was a great point you made as you interrupted him.
So the Earth, of course, the only viable option that you can actually postulate the Earth is the dielectric plane. We know what this is by actually looking with the ferrocell at how a magnetic field works. That we know we have a magnetic field, so it's where we would be able to sustain life. You can't explain it on a globe Earth.
Literally just a
He
mouthful of gibberish.
almost made it through.
You can't give any evidence to support it.
Just wait to the very end of it. As long as he's not running on, just wait to the very end of it.
But bottom line is though, in the flat Earth, we don't know what the moon is. You think it's non-physical. Some argue it's physical. Right?
So since I acknowledge I don't know what the moon is, because a hologram can do that. A naturally occurring hologram can do that. But I'm not saying it isn't physical. I'm saying I don't make claims.
What's the evidence? What's the evidence that it's a hologram?
We've actually observed lunar waves. Sometimes you can see stars through the moon. You know, so you just say that you know everything.
Can you show me evidence of stars through the moon?
Because a bunch of clowns said they landed on the moon, and you just believed it.
You've made him at one point. People are trying to address that one point. That's why they're interrupting you, because you said the thing about lunar waves and all this other stuff. And Cordis in here had actually, I don't know if he's the first one to debunk it, but he told me his debunking was pretty sound. He said that guy lives next to an airport. That what his name is, fucking 777, whatever his name is. He lives next to an airport. So when you're seeing those moon images or pictures or videos, whatever, what you're seeing is the atmosphere that's waving, not the actual.
Oh yeah, what airport does he live by?
I don't know. This is just what Quarters told me. I don't trust him.
Well, that is the only excuse you can say is like if a plane flies up in front of the moon, then its fumes, or you're gonna see some type of a wave.
Right.
That's not what this is.
Planes in his vehicle.
That's a cool story. So
if you look at the moon right above a diesel exhaust on a truck, you'll probably see waves in the moon.
It's just like if you look, there's over 10 flags, maybe not quite that much, where they show that the stars and the moon, right? Like whenever the moon isn't like where you can see all of it, where it's supposed to still be as a solid rock, you people claim, you can see a star. And also another thing is NASA says they have this thing real fast. NASA says they have this thing that goes around the moon, and that they have to turn off the camera on the dark side because they have to save energy. Then they come back around and they get to where the light is. It charges it back up, right? So that's why we don't get footage from the back, because it's so dark back there. They have to just push and save their energy to get back to the
dark side of the moon.
But the dark side.
There's no such thing as the dark side of the moon.
Yeah,
there's no such thing. China just imaged. China just imaged
without light.
Put a rover on the dark side.
Why are you obfuscating away from my point? What did I just say?
A bunch of nonsense.
I told you what NASA's official story is.
You say that you can see stars.
I told you what NASA's official story is.
I've been quiet for an hour.
What you said was that you can see stars through the moon that isn't illuminated, which is patently false, and that we have a orbiter up there that conserves power when it's not in direct sunlight on the back.
More than that. Hold on, but more than that.
I said, what NASA says is that they have to shut off stuff so that they can save energy till they get back to the light, and then they can charge back up, and then that's whenever they turn things back on. That's what they said.
You also said, can I have it floor for a second? You also said that's why we have no pictures of the dark side of the moon. And believe me, every time that we see a crescent moon, there's a dark side of the moon that we see as dark that isn't dark for someone else.
Dude, there's no specular highlights, dude. This isn't solid. It has waves. You can see stars through it. People have seen it hundreds of times. There's over 7 countries that have it on their flag.
When we see the moon as a crescent, this orbiter would be on the back side of the moon, the part we don't see ever.
You don't understand the moon, Zanik.
Can I finish my point? Thank you.
Please, Zanik.
You have this orbiter that is actually in the light. So the back side, not the dark side. The dark side is variable. This is another basic concept that seems to elude you, Witsit. Basic.
Wow.
So we do have
what a straw man, dude.
It's not a straw man.
Your straw man is that I don't understand your semantical diversion of the dark side terminology. Wow.
I wanted to show you something. You can listen to whoever's saying something, but I just posted a picture Dan showed to me. And he's pretty proud of it. He told me he's probably here to speak of it, but it's exactly what you said. Doesn't exist on the moon. The specular highlight.
But hold on, Coach. So he said we don't see the dark side of the moon because it's in the dark, and the spaceship turns off its power to save energy. So that's why we don't see the back side of the moon.
That's what they say.
No, they don't.
It's a simple fact.
They have a little model that shows you when it comes back around.
The point is.
No, they actually have an animation for you where you get to play it and watch it come back around and charge back up in the light, dude. They explain it.
Yes, but that's not why. No, we do have pictures of the back side.
There's like one where they say they were way behind it.
Because the dark side is not always the dark side.
They're not flying around the moon, dude.
It's not really hard to understand.
We're still moving away.
You people think we're flying around the moon.
Hold on a second, guys. Hold on. Witsit made a claim. The claim is that there's stars that can be seen through the moon. Now, I've watched the moon as an amateur astronomer my whole adult life. There's lots of amateur astronomers all around the world. They look at the moon every single night. No one has ever taken a picture of the stars through the moon. Okay, there's nobody that's ever seen
the moon isn't seen, but where the moon should be, you can see a star there.
No, that's never ever been recorded ever.
I think it has, but maybe I'm not gonna say I've ever seen it. I've
never had. Show the evidence.
Well, someone asked why. Look, someone asked why.
So why are you here peddling that bullshit when nobody's seen it?
Someone asked, because I've seen
all
when I go outside.
There's stars on the moon on a flag.
I've seen when I've gone outside is that like it's blue, and like it looks like it's just in this medium. Now you people can come up with whatever reason you want to, but like,
why do you
I just look at the moon and I don't make assumptions of it because I'm not done talking yet, though. So I'm not done talking yet, though. So I can practically demonstrate a hologram that will take the same properties when it comes to perception as a solid object. I've done it myself in my own hands.
You can on the star through the moon thing, man. To show the evidence of that.
Doesn't work.
No, I'm just saying I've heard that. I've seen like maybe it was a video or a picture, maybe it was fake. I don't know. I'm not gonna claim I know it was real. So I'm not gonna
we'll drop that.
I already said that.
There's no way you have a 3D holographic moon.
So anyway, I can actually replicate with a practical demonstration how you can make
what is you saying you see stars through the moon. You provide.
Okay, so how about we talk about how I've actually done it? So I practically demonstrated that you can have like an object that looks like it's just a hologram, and it's because of like a polar lens effect, which is naturally occurring. We have polarization in the atmosphere. So based on what is naturally here, you can have a hologram of an object that in fact is solid. But the hologram will look just like it's solid. And you can replicate the color change. I'm almost done, dude.
You're not almost
done, man. You can replicate the color change. You can replicate the color changes. You can replicate the shadows, it casting a shadow and the shadows on it. Okay, you can replicate the phases, and in fact, you can replicate the phases where it looks like a spherical change over it, where it's actually with like a ruler, something that's square, right? Like because it'll just make it look like the shadows like that, and you can replicate in numerous different ways every single thing that the moon does, and it looks just like it, but in fact, there is nothing solid there.
Right, so if you look at what Dan Fesser is posting to you, he's posted several the specular highlights. He's also posted about the blue through this moon thing. He's showing you how these things work without using magical properties of imaginary.
No, it's not magical or imaginary. I practically demonstrated it.
You brought up a hologram. Okay? That would be a magical property of a thing that doesn't exist. Instead,
how does it not exist? I made it myself.
There's no projector going to the sky.
I want you to do it right now so I can look up in the sky and see a duplicate of the moon up there that you've demonstrated.
Whoa. When did I say you could see the duplicate of the moon? I didn't say that.
You said that you've made a projector that could do this thing that you're saying.
Yeah, what I'm saying is
up there that we can all see right now. Let's
no, I never said you would see two moons though. So
not two moons. Make a new moon. Make a moon.
I already have.
Listen, there's no point in arguing that. You haven't done that. That hasn't been done.
Yes,
it doesn't exist.
I want you
but Dan's showing how it can be done with the reality.
Wait, Coach, are you saying it doesn't exist?
I'm saying that an object, a projector to create a 3D hologram that is where the moon is, it behaves the way the moon does. This is not a thing that exists. It's not a thing you invented. It's not a thing that exists.
I said the polar lens, the polar reflection through a polar lens will cast what is a hologram.
Right.
It will look just like the solid object.
I know. I understand that.
But it will cast shadows. It will cast shadows on the surface.
I'm telling you though that this doesn't exist in reality. There's not a thing that does this.
Wait, how do you know if it exists in reality if there's something beyond this, dude, and then we're in a container?
Yeah, that's an assumption. What I'm trying to tell you is that Dan, without making any assumptions,
You're
only using the facts that we know about reality,
No,
is
I'm
able
not
to give the
supposing
same.
anything. It's the only viable option to
Stop,
possibly have gas
with
pressure.
it. Stop.
It has to be contained.
Stop.
Yeah,
Stop.
it's
Stop with
definitely
it.
more
Dan,
viable
who
than
wasn't assuming
physical
anything,
objective
and not making
that we can
magical
bounce off of.
mechanics. Yeah, he's showing you that this stuff exists. That this you can make the same observations we get with things that exist.
Y'all don't know shit about the moon. You're just trying to tout consensus based on higher indoctrination, and you think that it makes me stupid because I'm not gonna fucking tout the majority mob mentality, low IQ interpretation of
Don't
something
address
that you
anything
don't
anybody
understand.
says, man.
No, you keep on
You're going
trying
in lemon mode right now.
No, you want to hand wave dismiss the possibility. All I'm saying is that I don't make definitive claims about what the moon is. It could be a lot of different things. I don't assume that it's solid. I don't assume what it's in. I don't assume what we're perceiving it through. I don't make unfounded presuppositions. That's the whole point. We don't understand the phenomenon of the perception of the moon. Period. And you think you do, but you don't. You can't explain the phenomenon.
You're claiming that the things that we understand about it aren't real, and you're giving reasons that that it's not real, and the reason
that they are real.
But recreate it with this magical thing. Or this or that, but everything
that's bullshit.
You're saying, all the problems that you've said about the moon are not problems. Dan has shown 3 solutions to 3 of your problems. You're not addressing any of them.
Oh, so, yeah, really? Okay. Answer this problem then, okay? So you're saying, if the Earth is flat, why can we see one face of the moon? Because you people operate at the Professor Dave level and think he's smart. And so then, here's the rebuttal, guys. Well, your claim is that it's tidally locked, a spherical object spinning within the gravity well of the Earth based on the distribution of mass, and that it has a gravitational relationship with the Earth, so much so that it in fact pulls the water, for all intents and purposes, to actually cause tides. So the moon's on one side of the Earth causing tides. The moon's on one side of the Earth causing tides, and then at the same time, simultaneously on the other side, there are equal tides of the same magnitude, and it's because the moon is pulling them towards it.
All you're doing, you're not displaying anything on the model. You're just displaying that you don't understand it.
Face of the Earth.
You can't answer that.
Actually, I can.
Let's hear it.
Everyone in the room can. Go ahead, rocket science.
It's the lowest rotational energy state. The moon rotates once about its major axis, with a minor axis pointed towards the Earth. That is stable orbit motion. That's what tidally locked is.
That wasn't my point.
You want the full dynamic equation.
You didn't even understand my point.
No, because you said
there wasn't an explanation.
Y'all can't answer it.
No, rocket. The point that he wants you to address is about the tides, about how to get equal on one side and one on the other. And this is what it's at. Make one fucking point. This won't happen again.
We can talk about that too. But he's jumping around. What does he want to talk about?
Well, no, this is all the same. This is because the tidal locking phenomena. You're saying the tidal locking phenomenon has nothing to do with the tides?
The way that the tides happen on the Earth is not related to tidally locked motion.
Okay, it is tidally locked to the Earth.
No,
that's
explaining. Listen to me. Tidally locked is not in reference to what the tides happen on the Earth.
I know.
But it has the word
tide.
But
it is inherently tied in, pun intended. No, I'm not, dude. Oh my God, you're an idiot, dude.
There are other moons in the solar system that are tidally locked that have nothing to do with water on the primary body's surface.
You just straw man the shit.
Explain to him about why there's the tides on the Earth.
No, I get to address the straw man, dude. So you always present that shit
because you're
so stupid that I don't understand it. But it's not what's happening. I didn't say tidal locked because the word tides in it, dude. But the point is the phenomenon of the gravitation. You have to always interrupt me. You always have to interrupt me. You always have to.
Because nobody wants to hear it again, man. Like we get it. You said a bunch of different things.
You people are scared of reality. Y'all religious zealots, dude. If I was so stupid, you wouldn't have to interrupt me.
I'm asking them to quit making non-points too. So please also stop just saying nonsense like that.
Why are you allowing Jake to interrupt me every time I start to give my explanation?
No, you're not giving an explanation. You're about to repeat what you already just said.
So you always think you know what I'm saying, and y'all always cut me off.
You started out saying what I said was. Yeah.
Witsit, you're calling us
because he's strawmanning what I said. Y'all make the conversation reiterative. When I'm over with closed or open-minded people that aren't morons and aren't religious zealots, they actually have normal conversation with me, bro. Like, we just talk about things. We agree, disagree on all kinds of things. We admit what we don't know. We don't know everything. We know the people that claim to know a whole bunch of shit are oftentimes proven wrong over time. We don't just go around staking claims that we don't understand. But you people do the opposite.
We're on to a totally different point now.
No, I'm go ahead and address the whole situation.
You question rocket scientists if tidally locked had anything to do with the tides. And because the word tide is in there, is that why you think it does?
No, and I said no. That's not what. Then I got cut off.
They're not related.
I didn't. No, they are related because that is yes, the tidal locking. Because the tidal locking is an effect of the gravitational relationship within the gravity well and the relationship with the gravity well of the moon. Relative. Stop interrupting me! Stop interrupting me, you clown show! Stop interrupting me! Yeah, in fact, the moon supposedly rotates.
Wait for him to finish.
The moon supposedly rotates because it has a gravitational relationship based on the mass distributed within a gravity well of the Earth, and then it's spinning at just the right speed in which we see the same thing. It's locked with the Earth and the movement of the Earth, and in fact the orbit within around the sun. So the point is, they also say that because of this relationship, this gravitational relationship between the moon and the Earth, which is because it is tidally locked, that's the explanation of seeing one face of it. Because of that gravitational relationship, it at the same time, within that same gravitational relationship, has an effect on the bodies of the water on the Earth.
No, so you're confusing the tidal locking with the gravitational relationship. Yes, there's a gravitational relationship with both, has an effect on tides as well as the position of the moon around the Earth in its orbit, but it's not what causes the tide. The tide, we could have something hit the moon and have it start spinning. That would not affect the tides. In other words, do you know why?
The moon doesn't have to be tidally locked to cause the tides. They're independent.
No, the point is that the gravity is what causes the tides, and the gravity is what causes tidal locking.
Yes.
Yes.
Okay, so they're inherently connected. They're intrinsic.
They're not.
They're intrinsic, bud. They're intrinsic, bud.
Locking.
No, my friend, if the gravity is what causes the tidal locking, okay, and the gravity is the cause of the pull on the tides, that is all intrinsic.
That's like saying if I have this gravitational strength, I'll always have tidal locking. That's not always true.
I never said that.
Always have
We're talking about the moon.
This wasn't your point before, anyways.
Yeah, my point is, if it's supposedly the gravity pulling the water that causes the tides, then how come they happen with the same magnitude simultaneously on the other side of the Earth away from the moon?
Witsit, if something hits the moon and started to spin, that would not affect the tides on the Earth at all.
Hey, man, if the Earth if the moon is pulling the tides of the Earth, okay, and that's the cause of it, then how come at the same time on the other side of the Earth it has tides simultaneously with the same magnitude on the opposite side of the moon?
Why is it when I take a water balloon and I squeeze it, it will start to stick out on the backside as it sticks out towards the front side as the middle gets thinner?
Okay.
No,
so you can't answer the question?
Jake, he finally asked a very good question, and that is a valid, your first one of the day that I've heard.
I tried to ask that like 5 minutes ago, Zanik. That was my question.
6 hours.
I just had to repeat it. Zanik. No, Zanik, this is how it always is.
No, it's not actually.
Yeah, I always ask a question, y'all can't answer, and then it's 2 hours of y'all not answering it.
You gotta go down this path, man. Like if
So
you
if the moon is
stick with what's being talked about instead of just to.
All right. Sorry about that.
If the moon's pulling the tides because of its gravitational relationship, then how come simultaneously on the other side of the Earth, the same magnitude, are the tides being pulled on the opposite side of the moon?
I just told you, Witsit, if you take a water balloon and you fill it up and make it nice round, imagine a nice round water balloon, perfectly round, full of water, and I pinch one side of it and start to pull it to stretch it out, it's going to get thinner on the top and the bottom, and it's going to bulge out on both sides.
Quite possible.
Great analogy. Witsit, do you understand what you're saying?
Hey, this is exactly what I asked you not to do before, man.
Yeah, I accept it. I accept it. I accept that at least someone answered.
Because when the balloon gets stretched out, the volume has to go somewhere, right, Witsit?
Well, I understand the logic of what you're saying. I mean, yes. I mean, that's at least you. Like I said, at least you answered. At least you answered. I give it to you, man.
Rocket scientist was about.
I mean, that's what you want to run with, though. I mean, dude, the moon. It's not like pinching it directly in the middle. It's not gonna be an even distribution at all. Like it's not right in the middle of anything. And it's gonna have a gravity. If it's strongest there, because that's where the mass itself is, that's causing displacement. The tides will be greater there, but they're not. They have the same magnitude simultaneously on the other side of the Earth.
You understand that it's pulling
a second harmonic response to the rotation of the moon.
Say again.
Don't say the big word. You know what harmonic means. You might get confused.
Zanik, please stop with the sideline commentary.
You need it. He's using the word harmonic.
What needs to happen is when somebody like Bizarre comes in and makes a point, Nobody else says anything until Witsit can respond to him.
Yeah. Do you agree with my? Do you understand what my rebuttal I'm trying to say is? It's like, well, I hear the logic and what you're saying. Like, so if you pull this bubble, if you will, towards you, like in the middle, like in the middle of the
not in the
axis,
middle.
right?
Just you grab the edge of the balloon that's closest to you, and you pull it towards you. And now remember, gravity is pulling on the backside, but not as strongly as it's pulling on the front side. There's an uneven amount of gravity pulling on one side than the other because the other side's further away, so it's not being pulled as strongly.
No,
right?
but there's supposedly gravity around the moon.
That's going to create a shifting displacement. That's going to stretch out the moon. It's going to make the moon squished.
I thought the moon had its own gravity
or the Earth, or whatever object we're looking at that's being tidally distorted, right?
Does the moon have its own gravity well?
Yes.
Okay, so the moon has its own gravity well. It's within the Earth's gravity well. You're conflating the two because they say the cause of the tides is the moon's gravity well. So if you're on the other side of the moon's gravity well, then how is the vortexual nature of the gravity well affecting the opposite side of the Earth at the same time with the same magnitude? It could not. It's
not the same magnitude. You just said that.
Oh, so you're saying that the tides are always.
There's a high tide and a low high tide.
And you're saying the high tides only happen at the magnitude they do whenever they're close to the moon itself. They don't happen on the other side of the Earth.
Yes, there you go.
That's not true.
Well, wouldn't you get the highest tides in between the tropics, since that's where the moon and the sun are around? Did I disconnect or?
Well, no. I mean, it makes sense. It makes sense.
You know what I'm saying? If the moon's pulling the water on Earth, and the moon's always in between the tropics, shouldn't that be where?
It's not between the tropics.
Dude, just imagine thinking that the moon's gravity well doesn't affect puddles, but it affects the oceans.
How would it affect the puddle?
It affects large bodies of water as well, like the Great Lakes, but to a very small degree.
Why would it affect the puddle? Because the puddle would be less.
Did you hear what I said?
Mass.
Did you hear what I said?
No, the puddle would be okay. The lake also.
We know why you think
that. There were tides in lakes.
Yeah. You understand explain why you think it. But Xenix said the exact reason. Everything with water.
So then I talked about a puddle though. So why is the puddle not affected?
It is affected, but not in a way that you're ever going to notice.
Oh, but so what I'm saying though, isn't the mass displacement of the puddle much less than the oceans?
Supposedly even your body feels tides, but it's so small that you're not going to experience.
But it pulls the ocean's mass displacement. It overcompensates for the mass displacement of the ocean much greater, and it pulls it. But a puddle's mass displacement is like laughable and basically negligible compared to that.
Remember
same
that?
moon, same moon.
Works in proportion to the mass. Remember that?
Yeah, that's my point. That's my point, dude.
Hold on. It's affected the same way because the puddle is only a few grams versus an ocean, which is obviously much larger. That's why there's more effect on it. Does that make sense?
The fact is that if something is if something's much smaller, then it's going to be affected greater by the bigger area.
That shows you're proving once again, Witsit, you're proving you don't have a fundamental grasp of the basics.
Okay, well, yeah, y'all just say that it's like the inverse square law is how you apply it.
No,
so y'all don't do that.
Newton's gravitational law has two masses, and multiplied by g. That's going to give it the magnitude divided by the distance. So you're multiplying the masses together. If you have a bigger mass, the magnitude is going to be greater.
So dividing it by the distance is the inverse square law.
That has nothing to do with what we're talking about. Though we're talking about the mass.
You just said it wasn't anything to do with the
that's part of the equation, but that's not the part of the equation we're talking about. We're talking about the part where you multiply the masses.
Coach, you're too complicated. Mass.
Too complicated. You people don't even understand your own religion.
Hold on.
No, what you're not getting is that the distance and the radius are being cut. The radius and the distance between are being kept the same. It's the masses that are variable in this situation. When you have a smaller mass when you have that smaller mass and you're keeping the denominator roughly the same, then you're gonna wind up with smaller gravitation. That's simple. Figure your stuff out.
Yeah, but that's actually the opposite of what we see in nature. That's what I was trying to get segue to. Thank you. So
give us an example.
Let me give you an example. Okay. So with the resting electrostatic potential, right, it's known that it's 10 to the 39th power stronger than supposed gravity. Now, they say that as you increase the mass, gravity strength increases. But with electrostatics, a resting potential or an incoherent compilation of matter, if you add to it, so as you increase the mass of incoherency, it actually gets weaker. As it gets bigger, it gets weaker. And that is known to be way stronger. That's known to be 10 to the 39th power stronger than what they even claim gravity is at a resting potential.
We're not talking about electrostatics.
You can never negate
we're
that.
talking in the realm of gravity, why a bigger mass would have a bigger force.
I said that what you're claiming is the exact opposite of what we do observe in nature.
We don't. That is not the opposite of what we observe in nature.
Yes,
we observe that exact property. That's why that law is the law.
So as the mass gets way bigger, right, we see a stronger pull. Can you please demonstrate that? Explain. Where do we see that in nature?
The moon is really big. It pulls on the tides, which are also which is part of the ocean, which are big. That's an example.
Go to your gym.
Okay.
Does the
even though it's on the other side of the moon, it does the same thing.
Does the 200 kilo mass weigh more than or less than the 1,000 kilo mass?
Oh my gosh.
The force is proportional to the mass.
You showed you guys were not ready for this conversation, so let's just not go there.
Ready to even being close to having this.
No, then I have to ask you what is weight, and I have to explain that to your assumption of what weight is what's in contention, and then you deny it, and then eventually you admit it, and then we say, okay, what is it? And then it's mass and gravity, and then we talk about how, well, that's just you reifying what you think the cause is. Weight's actually more of an acceleration. Even in your paradigm, if something's at rest, it's accelerating downward as the table or the floor accelerating upwards. That's what relativity actually says with your little idea of gravity, but you don't ever acknowledge that part. The point is that weight is basically acceleration, and really more so a certain amount of pressure that's mediated, put into a certain amount of area, and that creates a force.
You have to remember that's your point now. You just made two. We're not going to go on a different point.
Back to his
Mr. Watson, I didn't want to talk about it.
Pressure.
I was going to just explain why I don't want.
Yeah, I know, but
because y'all don't acknowledge any of this.
I have to go and run on points like that.
All right. Well, the only way you can even explain magnetic field, dielectric field, check. Gravity is the claim contrary to actual observable phenomena.
This is what I said. Don't do this. If somebody wants to respond to one thing you're saying, you're going on this. You're saying like 5 things.
I'll give you like 5 things. It should be easy to be an honest response to at least one of them, but I'd never get
4 or 5 bulls as he's speaking to us.
I'll give all of them so you can pick one out, so you people aren't so scared all the time.
Yes, there's no conceptual reason with Newtonian mechanics. You can add as many masses as you like.
Wait, you can add as many masses as you like and figure it out? Is that what you're saying?
Hey, Witsit, can you hear me?
That's inaccurate. Yeah, what's up?
So, maybe you can help me with this. Let's say you get an Olympic-sized pool, right? And you get a 1 million pound weight, like an iron ball that weighs 1 million pounds, and you put it on a scale, right? And it shows in the bottom of the pool that it weighs 1 million pounds. Now you take that scale and you place it, if the ball, let's say the ball is like, 20 feet high, right? So you place the scale 20 feet above the pool. Now fill the pool up with mercury, and then let the lead, of course not the lead, but the iron ball is going to rise, right? And it's going to apply pressure to the scale that is now above, now that the iron ball is moving away from the center of Earth due to the density of the mercury. Will the iron ball give pressure of 1 million pounds upward?
If you could actually keep that, if you could sustain the scale, then in theory, I would think so. Yeah.
So maybe it has everything to do with pressure mediation and not this thing that pulls things to a center.
Yes, everything is pressure mediation.
Pressure mediation. First of all, he's already said that force is the pressure of a unit area, and we already explained to him that was incorrect.
Instead of bringing that back up, why don't you just respond to what Mr. Rowdy said? Yeah.
Okay. It's not pressure mediation. There's something called buoyancy, which is a force that is vector upward in opposition to gravity, which is downward. The gravity is going to give mass weight. Mass times gravity. And that weight will be less on that scale based on the buoyancy, which is the amount of mass that has been displaced for same unit volume. And that's why you push upward.
But
so if you have 1 million pounds of this lead or whatever iron, and you have mercury, and mercury weighs a certain percentage of it, more per volume than the iron, then it will push it up with that exact proportion.
Now the medium, right? The ball, the iron.
I'm almost done. Hold on, I'm almost done. So that'll weigh exactly less than the displaced mercury by volume. That's it. That's simple.
But it's still pressure mediation, right?
What pressure
you're
mediation?
changing the medium.
Yes, it is, Zanuck.
How is it pressure mediation? Please describe.
Because pressure's being mediated relative to the mediums.
What is that? No. What do you mean by
Why does it have anything to do with pressure and not everything to do with density?
Well, density and pressure, you act as if they're just like disconnected or something.
What is pressure mediation? Please explain. Give me an example.
Yeah, like because of the amount of pressure, which is going to be relative to, let's say, again, a variance of factors, but your density, the density of the medium, right? And again, coherency, location, the vector, the medium is a big one. So.
It's okay. We're in the pool and we're at 33 feet down. Let's say we have it's a 10-foot object, and at one point this thing is 21 psi, and the next part is 30 psi, 20 psi and 30 psi. A 10 psi difference between top and bottom of that object. So explain to me how this pressure mediation will register on the scale. You said pressure mediation. Pressure.
There's a certain amount of.
Top of the object is 10 psi. Bottom of the object is 20 psi. Above ambient. Above 14.7.
Okay. So what's in the container and the container is going to mediate based on the pressure.
What happened? In this example, what happens?
What do you mean? What happens when you put that on a scale?
I just told you the weight of this thing is like I said, 1,000 pounds. 1,000-pound force. Let's say.
1,000-pound force.
Yeah, that's so. We on dry land we have 1,000-pound force. Now we put it in the pool of mercury. Or no, let's say water. Let's keep it simple. We all know about water. What is this 1,000-pound object weigh in this pool of water where we measure the pressure to be 10 psi at the top and 20 psi at the bottom?
What does it weigh? If it seeks equilibrium, the pressure mediates and it goes down to the ground, then it's going to weigh the same. It's all about its equilibrium being sought, man. I'm tired of having the same circular conversations with you, man. Equilibrium is sought. Equilibrium is sought. Pressure's mediated. Okay, the way the pressure's mediated is relevant. Listen, dude. Pressure mediation. Okay, so like if something was coherent, it would mediate pressure much more efficiently. Meaning that like the pressure would be forced to mediate much more dependent upon its coherency. That's why I say coherency. So when you bring up location, things quote unquote weigh in different locations on the Earth. Why is this? It's not because the Earth is a spinning ball.
On and on.
I'm not. This is all the point that I said. I didn't want to talk about it because you people. I said, and I quote, you people aren't open-minded enough to have the conversation. And this year is proving it.
You made up a term called pressure mediation. Nobody knows what that means except for you. And you can't even describe it.
The pressure mediates? You don't know what that means?
No, what does it mean?
It seeks equilibrium. That's like the 5th, 6th time.
How is the pressure mediated?
Yeah, relative to the other pressure around it.
What other
differential. There's a variance of factors, right? So, like, if you're putting energy into something, then there's pressure, right?
There's no energy in this system.
There's no energy in what system?
In this floating ball in the water, or sink, this iron ball at the bottom of the pool that weighed 1,000 pounds on the dry land, and now it weighs less in the pool. There's no equilibrium at all. It still has it.
Does the ball float or sink?
It sinks. We're talking about a water pool and a lead ball at the bottom of the pool that weighs 1,000 pounds. Just keep this thing simple.
And you're saying it weighs less on the ground?
There's a 10 psi difference between top and bottom.
Are you saying that it weighs less on the ground?
No, it weighs more out of the pool on the ground.
Right. So it weighs less on the ground of the water, basically.
Well, it depends on how you define weight.
Right.
No. What to laugh about? It still has weight.
That's my point.
Well, what's the pressure? What is pressure? So I want to know what your definition of pressure mediation means in that situation where pressure has not been mediated. There's still a differential pressure. You have two objects, or you have a medium and you have an object. How is there pressure mediation?
Pressure's always mediated. Like it's relative to the pressure of the medium. Pressure's going to mediate.
How is it mediated? Nothing changed. That pressure was always 10 psi difference at those spots, top and bottom of that object, whether the object was there or not. So the object didn't cause any pressure mediation.
I didn't say the object did.
So where's the pressure mediation?
I said it's relative to the pressure of the medium. Relative to it.
What do you mean relative? See, you're just making up words and terms. Please describe. Give me substantive specificity, please.
Okay, there's a certain pressure in the medium, and then the object is going to seek equilibrium based on a variance of factors like its density and thus its pressure, right, relative to the environment or the medium's pressure will attempt to mediate always. It'll always seek equilibrium until it finds rest.
See, the ball does not have a pressure.
Why are you enabling the charade?
Oh my gosh. It doesn't have a density. It doesn't, because if density is gonna make something fall down. If density makes something fall down, that's pressure being mediated.
No, what is pressure mediation? You haven't been able to describe it yet.
Yeah, just the energy. The energy will cause there to be mediation. Something. How is something falling no energy, Zanuck?
No, it's resting at the bottom of the pool.
Zanuck, you either get to your point as quickly as possible.
Point is he doesn't know what he's talking about, Coach.
Wow.
Have him talk about it.
Y'all don't know what you're talking about. So the resting electrostatic potential, resting, is 10 to the 39th power stronger than gravity here on Earth. So explain to me how you know gravity's even a thing if you can't exclude for electrostatic resting.
How much stronger is the strong force than that?
What?
The strong force?
You mean the one that's out in the medium?
Strongest force? How
The
much
one
stronger
that's out in
than
the medium that
electromagnetism?
you mean the one that's out in the medium that we can't verify?
No, it exists everywhere. It's not out in some other medium. But saying that something is stronger than gravity is an irrelevant point. Does not matter.
No, that wasn't. No, I explained why it's relevant. I explained why it's relevant because you can never exclude the resting electrostatic potential. So
He doesn't know what force you're talking about.
Indeed. Regardless,
electromagnetic force.
So we understand where magnetism, how it works, all this stuff, and we understand the ranges it works and the equations that cause it to work. And just because something is stronger, like a fridge magnet is going to be able to pick up a paperclip. This is true. If you put that fridge magnet a foot above the paperclip, it's not going to do that. So you're saying it's stronger, in general, but when you actually put it in context, it's actually not stronger in any context that matters on Earth.
Okay, so actually, the Earth is electrostatic. It's just very big, and so the strength or the pull of attraction actually it decreases, right? It's disproportionate to the increase in mass, right? The opposite of what they say about gravity. Now, it is 10 to the 39th power, stronger than what they claim gravity is locally on Earth at a resting potential. And so whenever I take the balloon, put it on my hair, it sticks to the wall, now you've increased the charge, it's overpowered, quote-unquote, gravity. Then it loses its charge and it falls back down to the ground. But the misnomer there is that it loses its charge because it never entirely loses its charge. It always has a resting electrostatic potential. So when it falls back to the ground, that's also electrostatic. That is inherently, undeniably... I'm almost done. That's undeniably electrostatic.
I'm not going to respond to it. I'm responding to what you said 30 seconds ago.
Undeniably, that's electrostatic acceleration.
Right. So what you said at the beginning of this fucking bullshit was that on Earth and here it's the force of electrostatic is 10 to the 39 stronger than gravity. When it's not just here on Earth, you're talking about the electromagnetic force in itself is stronger 10 to the 39.
No, I'm not. No, I'm not.
It's not just specific to Earth or something on Earth or anything.
No, I'm not. I'm talking about the electrostatics, and they say that on or out off. You don't even know your own religion, dude. So I'll give you another. What is it? Stanford, I think I have. So no, it's saying that when it gets off into the bigger scale, then it's no longer electrostatics is no longer needed to be taken into account. Gravity overpowers it. That's what it says, like Stanford. So I guess when I point out the resting potential, electrostatic potential is 10 to the 39th power better and stronger, and it says that word for word, then you should pump the brakes, man. I don't just make it up, okay?
Yeah, I didn't say you made it up. I said that you're wrong. You're saying it like in reference to the Earth. This is the truth. It's not in reference to the Earth. In general, those forces are it's that magnitude stronger. It has nothing to do with
Electrostatic.
Earth's gravity. It has to do with gravity in general.
Electrostatic. No, they say that on the bigger scale away from the Earth, that it basically reverses. Now electrostatics isn't nearly as strong as gravity. Electrostatics is no longer at play once you get out into the solar system and beyond. That's what they say.
Because that's how forces work. They work like gravity, for example. It works. It's got a certain strength, but that strength is determined also by the distance it is from the other object. So that's why when they say in general, and the same thing with the strong force. The strong force is much stronger than all of them, but really only on a scale that's only on from a range that's way too close to matter to anything. So, but yeah, like I said, those are irrelevant points for that reason. They're not. It has nothing to do with the Earth specifically. It just has to do with those forces in general.
Okay, so anyway, here on Earth, on the local scale, it's known that the resting, there's the document right there, that the resting electrostatic potential of anything that's electrostatic, right? Electrostatic resting potential, 10 to the 39th power. So the electric force is 10 to the 39 times stronger. Gravity seems negligible in comparison. It also explains, then in part 2, the part that I'm trying to make clear to you, is that it's different on different scales. The reason is that over linked scales much larger than the atom size, about 10 to the negative 10 m, the charges in each atom cancel each other out. All atoms have the same number of protons and electrons. So from far, this is like Stanford, dude. Or this is Boston University. This is Boston University.
Right.
I just linked it right there at 617.
I know. I've read it many times. Listen.
It's Boston University. So stop interrupting. Stop interrupting.
Stop
interrupting. Stop interrupting.
That picture when you get a chance.
All atoms have the same number of protons and electrons. So from far away, they look neutral. Therefore, the small contribution from gravity is all that remains. So it's explaining that on a different scale is, okay, here it is. Even though the neutrons are neutral, the protons and electrons can interact through the electrostatic force, which, as we know, as we just saw, is stronger than gravity. Yet, somehow, gravity determines how much or how most matter moves around the universe. The reason is that, over linked scales much larger than the atom size, the charges in each atom cancel each other out. Therefore, the small contribution from gravity is all that remains. So it's talking about on the bigger scale, it doesn't apply the same as it does here.
So that was my statement.
Way stronger.
So I appreciate you backing me up in there.
No, that was
earlier
my
you said that
original
was only applied on Earth, and I was letting you know that that's a general scale. There, it's generally that much time. It's generally that much stronger. It has nothing to do with. It's not specific to Earth in any kind of way.
No. In space, it isn't that much stronger, Kosho. So it does just apply to Earth.
It doesn't just apply to Earth.
Okay, but it doesn't apply to space. So then, what else is there?
It's proportional to the mass.
If it doesn't just apply to Earth, and it doesn't apply to space, then what else is there?
It doesn't just apply to Earth. It's a general statement.
Then what else does it apply to?
It's a general statement.
It doesn't work in space.
It's generally that much stronger.
It doesn't work in space, though. It's not like that in space.
It works that way everywhere.
No, it just said that it's not like that in space, dude.
Depending on the mass of the object and the distance. Same thing with the magnetism, depending on the distance from them and the charge.
It says in space that gravity's all that remains, dude. So, Boston University, been linked for 5 minutes now. 3 minutes.
I mean, I posted this from
it's
Stanford,
literally one
the
page.
university
So
you said originally,
that's-
Stanford University. So
it's literally one.
So
page.
you agree that space exists?
No, my point is that they acknowledge here, right here, they admit that on Earth, right, in the real world, electrostatics, its resting potential is 10 to the 39th power stronger than they even claim gravity is. But that they claim it just flips around when they go into space, and all of a sudden gravity's all that remains.
10 to the 39th?
I'm saying 10 to the 36, but regardless.
And that's electromagnetism, right?
It says 10 to the 39th.
That
It says 10 to the 39th.
Where?
So the electric force is 10 to the 39 times stronger. Gravity seems negligible in comparison. It's literally one page. It's right above part 2.
That document confirms that space exists.
No, what it says
agree with
is
it?
that to explain, no, it doesn't confirm that space exists. What are you talking about? It says that it's just different on the space scale because electrostatics gets overpowered by gravity, because they have to acknowledge why you would say that it was gravity. because how would you ever distinguish gravity? So they're acknowledging it by saying, well, on the bigger scale, it's different. That's within the assumption of reifying the paradigm that's in contention. It's called a hostile witness, because you people will argue if I just say electrostatics is stronger than gravity. You people will argue until I go get one of these universities. Then you'll try to spin what they say.
We've already said this to you. Like, if you look at either of those equations, they look almost identical. Coulomb's law or whatever, Coulomb's law, and also the universal law of gravitation. Almost identical.
I know, it was
the
reversions
difference
based
being
on
that in space,
electrostatic
the difference
attraction.
being that in space, you talk about masses in space, you're talking about stars and planets and things that have large masses.
Yeah, all you did was reverse engineer the electrostatic attraction, and then use basically the exact same equation, but make it way weaker because you knew electrostatics couldn't be negated. And in fact, it's 10 to the 39 times stronger. You reverse engineer the attraction, which actually gets weaker.
What's the point of this argument? So electrostatics
gravity is literally
What's
BS.
the point
and
of this argument?
Literally is BS because gravity's BS. You can never negate electrostatics, which is known to be much stronger.
Of course, you can negate it.
How do you do that?
Well, equal sums of positive and negative charge.
No, even if it's neutral, it still has a resting potential.
No, it's trivial to show that gravity is the only force responsible for the downward attraction to the planet, because the electrostatics and electromagnetics can be occluded and gravity cannot be. Gravity is the only monopolar force available. And there is demonstrably
monopolar. What is that?
Monopolar, yeah, it's unipolar or monopolar. Whereas
there's no such thing as a monopole.
Whereas electromagnetism and electrostatics are bipolar.
wait, there's no such thing as a monopole, bro.
Electromagnetism.
Yes, of course there is.
That's
yes,
not
there
true.
is.
No, there's not.
Of course there is.
Unless you're talking about electric charge.
No, he's saying in electromagnetism there's dipoles. In gravity there's monopoles. What he's saying.
Oh, gravity's not real.
There's no positive gravity, is there?
No, there's no gravity at all.
There is gravity.
No, there's electrostatic attraction.
Electrostatics can be easily occluded. They could be easily diverted, modified, concentrated, and shielded. Gravity cannot.
Okay, let me give you an example. You know what a gravimeter is?
Yes.
Okay, so you have the vacuum-sealed little box, and you're going to drop a little pebble. It's going to keep dropping and then picked up dropping, and then you're going to have lasers shoot across it using interferometry. It's going to make like an intersection pattern with the lasers, very precise, to measure the velocity changes, right? That little pebble is inherently electrostatic, okay? And when it's moving, then it's electrostatic acceleration. So if you didn't negate the pebble for electrostatics.
No, it's not.
Objectively, you did not. It is.
Just because it's moving doesn't make it electrostatics.
No. It's inherently, it has an electrostatic potential.
No, it doesn't. No, it doesn't.
Why not?
Well, you'd be able to measure it with a gold leaf electroscope.
So you're saying that lead, for example, doesn't have electrostatic resting potential?
No masses have electrostatic resting potential, do they?
Yeah, all matter. All compilation of matter.
And how do you show that? What does it show up on? What meter will show
all compilation of matter?
What meter will show you this static force?
You can use a Gauss meter.
No, you can't. That's a magnetic meter.
Yeah, but electrostatics is the same as
what? Come on, electrostatics. What meter? Come on. What meter measures a static charge?
Way worse earlier, right?
Can I insert a question in here? Can I insert in here, please?
Hold on. Let Witsit answer that question.
Yeah, so, well, you just assume that magnetism is non-related to electrostatics. It is not. But electrostatics, right, it's just not like a coherent perpetual motion.
No, I didn't say that. You suggested...
Even when something's neutral, it has
you suggested a Gauss meter to measure electrostatics. See you, Witsit. You're dumb.
If
Bye.
you do,
Bye.
Well, actually, no.
Good
What
evening,
I said
Brenda.
was, if you get a reading on the Gauss meter at all, that's inherently electrostatic. Now, if you do not, it does not mean that it's not electrostatic, because we just now explained how by using the, what is it called, the Coulomb's law, right? Like, they know how to quantify electrostatic potential. I just gave it to you. And so the point is, you don't negate it. I also gave you your best evidence of the so-called gravity. It's called a gravimeter.
And nobody asked you to recap the conversation, man.
It's called a gravimeter. So you didn't exclude it for electrostatics in a gravimeter.
Yeah, well, Bizarre asked you. You didn't answer. Bizarre asked you plainly. Bizarre asked you plainly if you could, how you would detect this. What you said, electrostatic resting potential.
Every compilation of matter is every compilation of matter.
He doesn't want to. Yeah.
No, every compilation of matter has the resting electrostatic potential.
That's fine. He wants to know how you measure it. Yeah.
But then, okay, you have to increase the charge. You can measure it.
But with what device do you measure it? Is what he asked.
I don't know how you would measure the charge.
I'm not asking you to answer. I'm just letting you know that that's actually what he asked. And that's what you didn't answer. Brenda has been trying to get in, so.
So that's a non sequitur diversion. Cool story.
No, that's actually what happened. That's what.
No, but I'm saying he was just diverting then because he's running away from the point, which is that you can't negate the electrostatic resting potential. I just now cited Boston University saying it.
I have a question about that. Do you have a site? Because I Google electrostatic resting potential and I get nothing, no returns.
You get no returns.
Do you have a citation? Do you have a citation?
I just cited Boston University. Have you not read it yet?
Well, Boston University is a very large university. Do you have, say, for instance,
have you not read it yet, though?
I have not read Boston. I have not read Boston University. No.
No,
I don't know
I
what
just
you're
posted the
talking about.
citation in there. Okay, well then you're asking for something I've already cited.
I don't see it. I did just get here. Where is this?
It's 17 minutes after the hour. Again, it has nothing to do with what we're currently talking about, though. But
yeah, it does.
No, it doesn't.
It's about the resting electrostatic potential.
We're now talking about electrostatic resting potentials. A second ago, we were talking about how much stronger electrostatics are than compared with gravity.
Yeah, they're way stronger.
Yeah, so that's not the same topic.
Like in the neutral, neutrally, it's way stronger than gravity, dude. That's what it says.
Yeah, like I said, generally that force is stronger.
No,
obviously,
always.
both those forces, both those equations have properties that you have to put into it, including the distance, and also in the case of Coulomb's law, you have the different charges. Okay,
yeah, so those, electrostatics actually, as you increase,
depending on the objects you're talking about, are going to change which one's actually stronger in that specific example. And whatever.
Okay, but Coach, you do know, for example, you do know, right, that electrostatics is always and only attractive, right?
What was the time stamp for that again?
Stop, please.
17 minutes after the hour.
What was that? What
17 minutes. 17 minutes after the hour. It says solutions CQ19.doc. It was posted by Witsit. For some reason, when I try to open it, it opens for a second and then just closes. Try to get it.
It's not a virus. Dude, it's Boston University, man. So anyway, dude, the point is, like, if something is inherently electrostatic and it falls down, right? Like it's static, right? But like now it's moving. Okay, so it increases the energy some because it's a movement. Okay, the energy of the fall or acceleration is going to affect its overall electrostatic nature and how it's lined up. Not very much, though. And the electrostatics itself only acts as an attractive force. Only. But when you increase incoherent magnets, for example, incoherent mass, as you increase the mass and add to it and add to it and add to it, it stays attractive always. But it actually gets weaker the more you add to it. So pertaining to the Earth, very big, it would be negligible, damn near, very, very weak, inherent electrostatic relationship between any object or compilation of matter that falls to it. It's electrostatic acceleration.
Yeah, none of that has anything to do with physics because electric charges can be positive or negative.
Okay, so electrostatics can have a resting neutral potential and it can always conduct electrostatic charge. And that means that when something's electrostatic and it falls, you're adding acceleration to it. It's attractive only, the Earth would attract it very negligibly. This would work on the local scale. That's why the equations are almost exactly the same. The difference is they say that as it gets way bigger and way bigger, gravity gets stronger and then extends out, and it's different out here in the solar system. Electrostatics gets overpowered, gravity is all that remains because the masses keep getting bigger relative to each other, and they proportionately cause a gravity relationship that makes them spin around each other, and electrostatics is nowhere to be found. So they acknowledge what it is on the Earth. You just have to find it, because people think that they just say gravity. Gravity's so much weaker. Nothing to do with what you call gravity.
Okay, I was going to ask you about the. You said something a second ago about electrostatics only attracting. That's not how I understand it. Maybe
that's not how electricity works.
Yep, it doesn't matter how. Okay, if you have an incoherent magnet, right? No matter how much you increase the mass, it's going to attract.
What does an incoherent magnet have to do with this?
That's false.
An incoherent magnet is electrostatic.
I know, but why does that have to do with this?
An incoherent magnet is electrostatic.
The way I understand electrostatics is like if you have some, I don't know, like a rod or something, you rub it against something else, you attract, the what do you call it? The electrons on one side, so you basically make it so it's got more of a positive side on one side, a negative side on the other side. But isn't that going to be attractive or repellent depending on what's it's reacting to? Like if you put a positive force to the negative side, isn't that going to be attractive?
Sure, but the point is, like, pertaining to the conversation, like the Earth itself has an attractive property that's electrostatic.
No, it doesn't. It's something that's electrostatic. It doesn't.
You're saying the Earth isn't electrostatic, Brenda?
You're talking about
Earth electrostatic.
Excuse me. You're talking about physics that doesn't exist in this universe.
Hey, Brenda, is the Earth electrostatic?
There are charges when clouds go across the sky. They build up by friction a charge, a differential in charge, and that's why we get lightning, because there's a charge, negative or positive, on the ground, and then a charge in the clouds.
Hey, Brenda, is the Earth electrostatic?
What does electrostatic mean to you?
You know what electrostatic means. As a resting charge potential, it's static. It's not dynamic.
Means. So your idea of what electrostatic is has no relation to electricity as it is
the same as dielectric.
In this universe.
You can't have electricity without electrostatics or dielectricity, dude. What a crazy claim. So you gotta have the electrostatics, i.e. the dielectricity, to even have electricity. To claim that they're nowhere related to one another is actually very dumb.
So you have absolutely no clue what you're talking about. An electrostatic charge.
Yeah, that's why you have to interrupt me.
Just a minute. An electrostatic charge is like a buildup of positive or negative ions, right, on the surface of an object. And so a surface of an object, say a plastic balloon, or the Earth, can have positive or negative charges built up on the surface.
If you increase the electrostatic charge of something, it will be attractive.
There's no such thing as an electrostatic charge. Electrostatic.
Oh my gosh.
That's right. There's either
You're
positive
wrong.
or negative charge. No, this is electricity.
No, there's neutral, and then you introduce some motion to it, and you're going to increase the energy, i.e. the electrostatic charge, and that's why the balloon can stick to the wall.
That's not how electricity works.
You just demonstrated you have no idea how it works.
No,
you said that electrostatics has nothing to do with electricity.
So again, you have a buildup of ions on the surface of an object. It will have an electrostatic charge. It will be either negative or positive. Do you understand that much?
You understand that it can have a resting neutral potential.
No, that's nonsense.
Well, then maybe you should read the link that you still haven't read.
Well, I tried to open it, and I got a bunch of goofy. Can you save it in a format other than doc? Save it in RTF or text. So, what objects have when they don't have an electrostatic charge is that they have a jumble.
Never.
They have. That's not true.
Name one time that something's not electrostatic.
When it has neither a positive nor a negative net charge.
Name one example of something that isn't electrostatic. Name one.
Everything around you right now has zero electrostatic charge because it has an equal amount of negative and positive.
An charge potential, Brenda.
Stop talking like that, especially when you're fucking wrong, dickhead.
I mean, I've said it 5 times.
Nonsense.
Dude, how is it nonsense?
Let me explain it to you. Because
No, I'm not letting Brenda explain something to me. She doesn't understand it at all.
I'll explain it to
Literally
you.
not at all.
Yeah, go ahead.
All objects will have a mixture of positive and negative charges at its surface equal to 0. And then when you apply friction, you rub off those charges and you create a difference, which is you'll have positive on one object and a net negative on the other, and that's how you get astatic electric discharge.
And then you can transfer it to any material known to man, and that's because it has a charge potential and it can conduct the electrostatics. You're a crazy person. In addition, you can't talk about electricity without acknowledging electrostatics. It's called dielectricity. That plus magnetism. The hybrid of the coherency is how you get electricity. You people don't want to know the truth, but I've been in it for hours. I'm getting out of here. Brandon, you exhausted me. Congratulations.
Before you get out of here, Witsit, there's people who want to address this paper that you posted, which has nothing to do with the Earth whatsoever. And I don't think it does not even state anything that you said.
Okay,
yeah,
well, actually, you are lying. So the paper clearly says that.
Somebody posted a picture in the chat of it. Yeah.
Okay, yeah. So read it.
I opened part of it, and I got a jumble of what looks like to be.
No one cares.
Word
we can find the gravitation. I'll just read it. We can find the gravitational attraction using the universal law of gravity.
Yeah, but look at what it's saying. It's using masses that are dozens and dozens of times smaller than even anything you'd ever experienced. It's obviously not talking about the Earth.
I said on the local scale of Earth.
But look at the masses that they're using for this.
But it's because this is on the local scale of Earth. Then in part 2, they say it's different in space.
It has nothing to do with Earth whatsoever. Look at the masses it's using.
Part 2 is saying it's different in space away from the local scale. Well, the local scale is on Earth, Kosho.
Look at the masses that it's using. None of those masses are Earth's mass.
I didn't say it used Earth's mass, dude. I didn't say it's taking the electrostatic potential of the Earth itself. I said this is on the local scale. This is on the local scale of the Earth.
It's not.
I'm not clear.
Okay, y'all are just lost always. Peace out.
How do you post this thing, man? There's no.